DevOps is not about containers and AWS or Azure or Google and Kubernetes and Prometheus and all those things. That's not what DevOps' goal is. The goal is to enable developers to be self-sufficient, to be able to do whatever they need to do, and to have freedom to do it on their own terms. Let's talk about how we should be doing DevOps and what should be the goal set in front of us. What is the first association when you hear things like containers, Kubernetes, cloud, GitOps, CI/CD, logging, monitoring, infrastructure as code, troubleshooting, security, service mesh, and so on and so forth? For many of you, you're probably thinking, hey, that's me. That's DevOps. That's what I do. I manage those tools. I do stuff with those tools. But that's wrong. That's not DevOps. That's operations. Operations need those tools. What you should be doing, like operations person or SRE or DevOps or whatever we call ourselves these days, is not to give those tools to everybody, because everybody is never going to figure out how Kubernetes works, all the details about it, and all the details about AWS or Azure or Google, and how to troubleshoot and how to monitor and so on and so forth. We cannot shift left by giving those tools to everybody, so they are reserved for operations one way or another. But the question is, what do we do with developers? Do they continue just writing JavaScript or Python or Java code of their applications and throw it over the wall to other people that are specialized in operations or cloud or security? Or should we enable developers to be able to do those things by themselves, to manage their clusters, to manage their servers, infrastructure in general, to deploy their applications, to run CI/CD, and so on and so forth? And if we do agree that DevOps is about combining development and operations, and that the goal is to create self-sufficient teams, we cannot say, hey, you just do it from now on. Here's an AWS account, create your Kubernetes cluster, define your applications running in Kubernetes or serverless or whatever we're doing, monitor yourself and so on and so forth. Just spend a couple of decades learning the tools and then you will be self-sufficient. That's not going to work. That never worked, and it will never work because it is impossible for everybody to know everything. So here it goes. DevOps is about creating services that others in our company can consume. Those services can and should use different tools to accomplish the mission, but they cannot be exposed directly to everybody simply because it is impossible for everybody to learn everything. So ops, and in this case I'm using that term very broadly to describe all the people who are sitting on the right side that are in charge of cloud and Kubernetes and monitoring and this and that. All those should be creating services that developers can consume, and that should enable them to do everything themselves. Everybody has a customer, and your customers are developers, and you need to make sure that they can self-serve their needs. So here it goes. DevOps is all about creating IDP, which stands for Internal Development Platform. It's internal because it is meant for internal usage. It is developer because application developers are the consumers of that platform. An internal developer platform, or IDP, is a layer on top of all the technology and tooling that the engineering team has in place. Or maybe that's not the case. We're going to discuss that later. For now, what matters is that IDP is a platform that enables everybody to do operations that they need. It's about shifting left and doing it for real. It's what operations and SREs and DevOps and security teams create to enable developers to self-service themselves. You can say that IDP is a self-service platform for everything. Now you might be asking, hey, why would we do that? Why would we enable developers to be self-sufficient. And there are quite a few reasons. And the first one is that we want to free operations to do what matters. And what matters is creating a service that others can consume instead of waiting for somebody to open a Jira ticket like, hey, I want this application deployed there. Hey, there's something wrong over here. Or hey, I need a cluster. It is much more efficient to create service for others to self-serve their needs than to wait until somebody tells us what to do, and that somebody being blocked while waiting for us to do something. There are numerous studies that show that IDPs increase productivity, often drastically. They reduce lean time, they increase deployment frequency, they decrease mean time to repair or MTTR, they decrease change failure rate or CFR, and so on and so forth. So let's discuss how we should build an IDP that is tailor-made for a specific organization. On a very high level, the goal is to provide a service that enables full life cycle of everything. That means change of desired states, performing certain operations or actions, converging the actual into the desired state, and being able to observe the actual state of the system. Let's start by talking about the actual state. The actual state are all the resources running in our system. We can divide that actual state into providers like AWS, Azure, Google Cloud, maybe on-prem, Datadog, Elastic, Splunk, and so on and so forth. So we have a number of providers that we are using for our system. And on top of those providers or below those providers, depending on how you look at it, we have infrastructure. That's servers and clusters and databases and so on and so forth. And finally, we have applications. They can be our applications, applications that we are developing, or some third-party application. We might choose to run database, let's say Postgres database, ourselves instead of using a service from a provider, and that would be an example of a third-party application. We did not develop that application, but we might need to run it nevertheless. All that together is the actual state. That's what is running somehow and serving certain business needs. And to make the actual state, to make it run somehow, we need to define the desired state. The desired state is all about defining what the actual state should be. We do it by writing code, by writing some manifests or configuration files, and so on and so forth. The goal is to describe what we want and then have some processes or some services that convert those desires into reality or into the actual state. And here we are facing a huge problem. The manifests that define the desired state can be complex, very complex. For example, if we want to define a Kubernetes application, we need to define an ingress and a service, deployment, or a stateful set. Maybe we're using service mesh, in which case we would need to define a virtual service, and then we need to figure out what to do about storage, to mount it somehow into containers. We need to build container images and so on and so forth. And that's only an application in Kubernetes. That application might be running as serverless somewhere else, and then the manifest will be completely different. Or we might need to define a server or a cluster. Let's say a cluster, EKS cluster in AWS. To define a cluster, we need to figure out how to define EKS itself, and node group, an internet gateway, and a VPC, and subnets, and so on and so forth. There are a lot of moving pieces that we need to gather together, define them, and put them into logical grooves, and only then we have something meaningful. Now, the problem is that all those things are typically building blocks. We cannot really define an application in Kubernetes. We cannot define EKS cluster as a cluster, and so on and so forth. We need to take many different pieces and put them together. Unless you're specialized in AWS or Kubernetes or serverless or this and that, it would be very hard to imagine a person knowing how to do all those things. So we need to simplify how those manifests are generated, and we are going to get back to that later. What matters for now is that the desired state is a collection of code and manifests and configs and so on and so forth, and those manifests define the actual state, a cluster, a network, an application, and so on and so forth. Now we need to store that desired state somewhere, and the only reasonable place to keep it is Git, because Git is where we keep code, and code is something that can be interpreted by machines, and that means that almost everything we do is code, because almost everything we do is one way or another interpreted by machines. Now let's move into the area of tooling. Let's talk about tools, because we cannot avoid having tools. We need tools. There are many different types of tools, and typically we start with what we already have, and that can be almost anything. I will put them into different groups. We have things like pipelines, for CI/CD, for automation of the steps, a collection of steps executed whenever we make a change to a Git repository. We have GitOps that is in charge of synchronizing the desired state with the actual state. We have infrastructure tools that are making sure that our infrastructure is up and running. We have RBAC for security, authentication, and so on and so forth. And there are quite a few other types of tools. However, for IDP, those are the most important types of tools. We need pipelines to automate stuff. We need GitOps to synchronize the states. We need to manage infrastructure, and we need to manage access through RBAC or something similar. That does not exclude other types of tools. We need more than that, but those are the main areas that we should be thinking about when we think about IDPs and enabling self-service. IDP is what puts all that together, and everybody interacts with IDPs through a UI. So let's talk about UI. So IDP is a single pane of glass that unites everything. It enables developers to change the desired states and observe the actual state. Now you might be asking, hey, what should be the form of the user interface that we use? And that could be anything. It really depends what you're comfortable with. It could be a web UI or a CLI or IDE, or more likely a combination of all those. Somebody might prefer to run things through a terminal. Somebody else might prefer to click things in a web UI. And most of developers like working with IDEs like Visual Studio Code. So the user interface can have different forms. Now, here's the important thing about user interfaces for IDPs. They cannot be only links. You cannot just create an interface that says, hey, here's a link to Jenkins builds, and here's a link to your Terraform manifests, and here's a link to this, here's a link to that. That does not enable people to be self-sufficient. That does not enable self-service, because the complexity is still the same. If it was complicated to use Terraform directly in the past, it's not going to be less complicated if you put a link to Terraform. And the same thing goes for Jenkins or CircleCI or Prometheus and Grafana and so on and so forth. Now that's where almost everybody starts. We use something like Backstage, and here's a link to this, here's a link to that. That's not helping much. That's not what IDPs are about. IDPs are about creating services that everybody can consume. And to make that happen, we need to make things easier, to make things simpler. And that very often means hiding the operational complexity, hiding all those tools and the interfaces behind all those tools, and creating new interfaces on top of them that will be tailor-made for what everybody can understand and use. Now, for all that to work, we need an API below that user interface. We cannot create an interface that just executes CLI commands, because that's not enough. For now, everybody understands the importance of having an API that allows us to perform certain actions, to query it, to find some information, and so on and so forth. Now, the problem is that we cannot rely on many different APIs. If we have 75 different tools, we would have 75 different APIs. That would never work. We need a single API that the UI will talk to, and the only candidate today that we have is Kubernetes. Kubernetes is the only universal API that we can rely on. Everything else is fragmented or serves specific needs. Kubernetes API is the only universal API we have. However, when I say that we must standardize on a single API and that the API should be Kubernetes API or KubeAPI, I am not saying that everything should be running in Kubernetes. That's not the goal. Kubernetes is not trying to be the only platform you should ever use to run your applications, but it is trying to become the only API that matters. We can use Kubernetes not only to run containers inside of a cluster, but to manage everything. That's what it is designed for. It was designed to be extensible, and today we can extend it to interact with almost anything. So let's talk about KubeAPI and see why am I saying what I'm saying. So why am I saying that we should use KubeAPI for everything, especially as the only API for IDPs, as the only API that we should communicate with when using IDP UIs like Web UI, CLI, or IDE, and so on and so forth. There are quite a few reasons, and the first one being that Kubernetes API is on a path of becoming a universal API to manage everything. It has continuous drift detection and reconciliation, meaning that it can take over part of operations that we normally do today. It makes sure that things are always running, and if there is a drift between what we want and what something is, Kubernetes will reconcile that and making sure that the actual state is always the same as the desired state. It was designed from the very start to be extensible. We can extend KubeAPI to manage any type of resource by creating new custom resource definitions. And finally, this is important, remember this, Kubernetes is not only about running containers. Kubernetes is a powerful universal API with a very good scheduler that can manage anything, and containers are only the first wave of adoption. They're just a small piece of what Kubernetes can and should manage. So let's talk about custom resource definitions and custom resources, or CRDs and CRs. Custom resource definitions, Kubernetes custom resource definitions, or CRDs, are the key in this story. And to understand that, I must ask a question. Who writes manifests that represent the desired state of something, of an application, or a cluster, or a server, or whatever that something is? And if the answer is everybody should be able to define the desired state for the things that matter to them, then we need to simplify those definitions, those manifests. And that's where CRDs come in. Kubernetes custom resource definitions allow us to define almost anything. Hey, what does it mean for you to have a backend application? This, and that. Excellent. I can create a new custom resource definition specifically for that. What does a database mean for you? This, and that. Excellent. I can create yet another custom resource definition. I can create a CRD to define whatever I want, whatever we want. We can create completely new definitions that are tailor-made for specific audience and the level of knowledge and experience of that audience, which in this case are developers. So if resources currently available in Kubernetes are building blocks, CRDs are an opportunity to define what something is, to define compositions and the relation between different building blocks, and expose all that into a new definition that is tailor-made for everybody. And that means that we have an opportunity to simplify everything. We have an opportunity for ops to combine building blocks into compositions, and for developers to write manifests based on those custom resource definitions and convert those manifests into custom resources that will do whatever they need to do. Hey, you need a cluster with networking and storage and monitoring? Excellent. This is the resource definition that you define. When you create an instance of custom resource based on that definition, all those things will happen. You do not need to worry about those building blocks. You can focus on what matters. Now let's talk about the tools. Which tools should we use to put all this together? I will ignore for a moment that you most likely already have a lot of tools and you cannot get rid of them. You do not want to get rid of them, and those tools can be anything. But I will ignore that and imagine that we are starting from scratch. How would we do things if we would start today? And there are a couple of areas that we need to think about. To begin with, how would we define application and infrastructure specifications? And that's something that I already covered previously. We should define all those things as Kubernetes custom resource definitions and then create manifests based on those CRDs and convert those manifests into custom resources that will do whatever needs to be done. Kubernetes CRDs and CRs are the abstraction layer that we need to hide the details that do not matter for general audience and simplify everything in a way that everybody can self-serve their needs. Next, we need pipelines that will perform certain actions. Like, hey, I need to run tests when this happens, and I need to build some container images when that happens, and I need to do this, and I need to do that. And most of those actions being triggered as a result of some events. Like, hey, I just pushed something to Git repository, or this happened over there, and so on and so forth. Now, since we already standardized with Kubernetes being the integration layer, Kubernetes API and scheduler, then those pipeline tools, which we typically call CI, CI/CD, should be based on Kubernetes as well. Or to be more precise, the way how we define those pipelines should also be based on custom resource definitions and then create as many custom resources as we have built in a system and so on and so forth. So if you can choose, I would probably go with Argo Workflows and Tekton, and if we cannot choose, then use whatever you already have. There is advantage in going Kubernetes native, but those solutions are often complicated, very complex, and if you cannot handle that complexity, then any other solution should do, like Circle CI or Azure DevOps. Does not matter. Most of the tools in that area are easy for developers to use because pipeline is just a set of actions or scripts that should be executed in certain order. And then we need to think about synchronization. How do we synchronize the desired state and the actual state? How do we make sure that the actual state is always the same as the desired state? And that area today is very clear. That's either Argo CD or Flux, and potentially Rancher Fleet in the near future if it matures. But that's probably the easiest choice simply because everybody today uses Argo CD or Flux. If you're not using those, you should. You must. Next, we need to figure out how are we going to orchestrate infrastructure? How are we going to create abstractions on top of infrastructure for the same reasons why we are creating abstractions on top of everything? And since we are standardizing on Kubernetes, that should also be based on Kubernetes custom resource definitions, and that means that we should be using Crossplane or SEK from AWS or any other infrastructure as code tool that can run inside Kubernetes and that is capable of extending itself through resource definitions. The choices around application orchestration are even more limited. If the goal is to tailor-make something for our own needs, the options are narrowed down to Open Application Model with Kubevela or Crossplane. Both of those allow us to create new custom resource definitions that define what an application is or anything else in an easy way, and more importantly, in a way that can be consumed by everybody. And finally, we have RBAC or access control, which is relatively easy and straightforward. If everything is stored in Git and Git contains the desired state, then we always write things to Git. Then Git is the only one that has write access by humans, and that means that we just need to make sure that correct people have correct permissions to access specific Git repositories. There is no need for majority of people to ever access directly Kubernetes or cloud or what's or not, except in read-only mode. We still need access to Kubernetes that is sitting below IDP simply because IDP needs to observe the actual state. So we humans need access to see what's going on with all the resources floating around wherever they are. But that is read-only access and that shouldn't be a big deal to set up. Now let's talk about the process. How would that process look like? How would people interact with IDP and what should IDP do? Everything we do is based on two things. Either we are changing the desired state or we are observing the actual state. And if you focus on changes to the desired state, it starts with the developer writing code and pushing it to a Git repository, either directly, git commit, git push, or through IDP UI, whichever UI you are using. It could be CLI or IDE or Web UI. In any case, if you go through IDP, the result should still be the same. If you define something over there, that something must, and I repeat, must be pushed to Git as well. It does not matter whether we interact with Git directly or through a UI, the end result must be pushed to Git. If you have a web UI of any sorts that is not pushing changes to a Git repository, you should ditch that UI immediately unless you're using to observe something like, monitoring tools. If it's for observability, that's okay. If your intention is to change the actual state of something, then your new desired state must be pushed to Git. That's where most web UIs are failing big time. Now, once we push things to Git directly or through IDPs, pipelines are executed. Those are one-shot builds with steps that do things like, hey, I need to build an image, I need to run some tests, I need to push some artifacts to some registry, and so on and so forth. And pipelines themselves might also change the desired state in Git. If a pipeline is building a new container image and pushing it to registry, and we want that image to be applied to an environment, then pipeline itself should change the image tag in a manifest stored in a Git repository, and that manifest defines the desired state of an application. Apart from pushing application code, Java, Python script, developers might be writing manifests or updating or modifying manifests and pushing that to Git as well. Just as before, it can be pushed to Git directly or through web UI that has a form that allows you to create manifests in an easier way. It does not really matter how we create those manifests. What does matter is that they are converted into code, and by code I mean something that can be interpreted by machines, including YAML, and pushed to a Git repository. Those manifests must be based on custom resource definitions that define what something is. This is an application, this is a cluster, and so on and so forth. It must be based on custom resource definitions. That's the only reasonable way for us to simplify things. Now, independently of whether manifests were created directly or updated by us or by pipelines, GitOps tools should detect that there is a drift between what manifests define, which is the desired state, and what the actual state of custom resources in Kubernetes is. We can call this the GitOps actual state, right? That's the state of the resources in a Kubernetes cluster. And remember, those custom resources might not be only containers with applications running in your cluster. They could be AWS resources, they could be Git repositories, they could be databases, and so on and so forth. Custom resources are tailor-made resources that describe the desired state of something. Now, once one of the GitOps tools detects that there is a drift between what is a manifest and what is a custom resource in a Kubernetes cluster, and remember that custom resource is still not the real actual state that is coming later, that's still not the database. What matters is that GitOps tools are making sure that those two states converge, what is in Git and what is in a Kubernetes cluster. From there on, the job of that custom resource is to create something real, which could be a cluster with VPCs and subnets and what's not, or it could be a database server with certain databases inside and certain users configured, or it could be an application that consists of ingress deployment and services and so on and so forth, or it could be a serverless application running in Google Cloud Run or AWS Lambda and so on and so forth. The job of custom resources is to make sure that the actual real resources, physical resources, are running somewhere. So that is the process. That's a high-level architecture. And now we can talk about user experience. What do we actually do in IDP? How do we interact with internal developer platforms? IDPs are in charge of three major areas. To begin with, they help us write manifests based on custom resource definitions defined by operators, and they help us push those manifests to a Git repository. Second, IDPs help us with observing the desired state, which is based on manifests in Git. It enables us to see what the system should be. We can zoom in and out and see only a part of the system or the system as a whole, but the point is that it helps us visualize the desired state, which is based on what is stored in Git. And finally, it helps us observe the actual state. That's monitoring, troubleshooting, logs, and so on and so forth. It helps us collect all the information that we need and present that information in an easy to digest way. What matters is that all those things are tailor-made for specific developer needs. IDP is not about enabling operators to do the things that they already do. IDPs are about enabling developers to do the things that they're not expert in doing. And even if they are experts, it makes things much easier, much simpler, and much more efficient. And now you might be asking, hey, where do I get that? Where do I get an IDP? So let's talk about that. So your first instinct might be, hey, I will just buy IDP. Where do I buy IDP? And that's a good choice. There are solutions that you can purchase and just use right away, but they work well only for small companies that are starting from scratch. And the reason why I'm saying that is that those solutions, those that you can buy and start using right away, like Heroku, for example, are highly opinionated. The only way to make something extremely simple from the get-go, from day one, is to make something extremely opinionated. Very, very, very opinionated. And it's great when something is very opinionated because it's easy. But the problem with that is that we need to adapt to the solution. Solution does not adapt to us. And that works well if you're a small company or you're starting from scratch, because you can say, hey, from day one, I'm going to do things Heroku way, or whichever solution you chose. But if you already have things, if you already have the system, you need to have a tool that adapts to you. And that means that you need to build it yourself. Building an IDP is the preferable way for bigger companies, especially those that already have assets in place, already have applications and systems and so on and so forth. Because if you build it yourself, it can be tailor-made to your own needs, and the solution will adapt to you instead of you adapting to the solution, which, let's face it, will never happen if you're a big company that already has years and years and years of investment. Now, when I say build it yourself, I am in no way saying that you should build it from scratch and create a new file main.go and start and build it from scratch, because that's insane. That would never work, because that's too much, and we already have tools that can help us build our own solution, but still based on existing tools that are made specifically for those use cases. We need tools that help us build opinionated platforms instead of using off-the-shelf solutions, which work great, don't get me wrong, but you need to be small or you need to be starting today. And that solution that you're going to build must follow certain rules. It must store changes to Git. So it doesn't matter if you go to web UI and fill in some form and click a button, that button must push it to Git. The desired state must always, always, always go first to Git. You must be using Git as the only source of truth of the desired state. That solution must have a universal API. An API that allows us to do everything and interact with everything, no matter whether we go through one type of UI or another type of UI. And that solution must be a control plane. It cannot just blindly do things. It must be acting as a control plane, ensuring that things are happening in specific order, under specific condition, monitoring the drifts and reconciling the states and so on and so forth. We must have a control plane. So storing Git, use Git as the only source of truth of the desired state, have a universal API, and have a universal control plane. So what can we do today, or should we wait for tomorrow? Let's talk about the present and the future. So if I would start building an IDP today, not yesterday, because yesterday we were doing those things differently, and not tomorrow, because tomorrow is still not today, but today I would be using certain key ingredients. The most important ingredients would be probably Backstage, that would give me the flexibility to create that UI that unifies everything. Cross-plane, that would help me create custom resource definitions and custom resources and act as a control plane and so on and so forth. Argo CD or Flux, both are great for synchronization between the states. And I need pipelines. I'm not very opinionated about the pipelines. You can use anything. Jenkins is fine, Circle CI is great, Azure DevOps is good, and so on and so forth. There are plenty of pipeline solutions. Use whatever you're familiar with. But if I have to make a choice, if I would be starting from scratch, then that would be Tekton or Argo workflows, because they fit well into that Kubernetes ecosystem. And on top of all that, you would have a bunch of other ingredients, and that could be anything else. That really differs from one organization to another. So there's much more to it, but the key ingredients would be Backstage, Crossplane, Argo CD or Flux, and Tekton or Argo workflows. But how about tomorrow? What is coming? And I'm very excited about tomorrow, because I believe that will be one of the next waves. In 2022 and beyond, we will see a huge surge in interest, demand, and solutions for IDPs. That part of the market is going to explode for a very, very, very good reason. IDPs are in a way evolution of Kubernetes. That's where Kubernetes is going. And remember, I'm not advocating that you should run everything inside Kubernetes. I'm just saying that Kubernetes will evolve into becoming a universal control plane, a universal solution to manage everything. Not only what's inside that Kubernetes cluster, but outside as well. The next steps is first for you to explore different types of tooling, especially those presented in this video, and then combine them all together and start building your own personal internal development platform or IDP.